And as I said in that email, of course, I will work this out a little later today. Let me, first of all, move to the textbook. We, I guess, didn't see it over weekend. You probably are missing it. I really like this textbook. So what I think is I should take a look a little bit at section 11.6 to start and wait for some other people to join us. So we have next section, 11.6. So we work on chapter 11 and this section 11.6. Well, continues the story of solving the systems of equations, but what it has a little bit different type of display. We have here the system with two unknowns like x and y as usual. Start with 3x minus y on one side, and this is equal to -2. The other is 3x squared minus y and this is equal to 0. So what we want to do is try to find both unknowns, x and y. And of course, to be able to do this, I want to eliminate y's. In fact, looks like the system begs me to eliminate. So if I subtract same thing from the same thing, then we're going to have no unknown y, but just 3x subtract 2x squared, actually 3x squared. And this is equal to -2 subtract 0, which is just -2. So when I do this subtraction, I definitely need to notice that now we have a quadratic equation to solve with x squared. So what I can do is bring all of these terms to the right side, because when we solve quadratic equations, we always want to start with positive x squared term, right? So I'm going to bring these guys over here to the right. So I'm going to have only 0 left on the left side. And this is our start. So the question is, how can I solve this equation with x squared in it? I think I didn't write it correctly. I think it's 2, because otherwise I'm not going to have the right solution, the same solution that they have. So I should be careful. So I just looked at this equations and wondered, looks like it's not factorable, so it is better be turned to 2, right? Way it was originally. So instead of -3, I just put 2. And this way, I think I'd be able to factor my equation. The only way to factor 2 is 2 times 1, so it'd be 2x. And then x in the other parentheses, right? And then the other -2, I'm going to factor as a -2 and +1 as well. +1. So now I have 2 little equations to work out. First of them is 2x + 1. Notice that it's a little bit different, because now instead of having only one solution, I'm going to end up having 2 solutions. So that's definitely something new. So x minus 2 is equal to 0. And that tells me that x is equal to +2. And this is great. I like this answer. Well, the other is going to be a fraction, but it's fine. We know that fractions also always around, right? So it'll be x is equal to -1. But now the question is, what about y? How do I get y if I have two values of x? And it turns out there'll be two answers, n for x and for y. And that's what actually they show here on the picture. There are 2 points of intersection of that line with a parabola, because actual second equation has x squared in it, so it is parabola. And remember, solution for the system is a point of intersection of my curves. And I got 2 points of intersection, as we can see in the picture. So we just need to get their y coordinates, and how to find those y coordinates. Well, I guess I better use my first equation. I can pull out y from it. It's going to be 3x. And if I bring over +2 to the left and negative y, I will change with a positive y. So this way I got my, I think it's kind of hard to write. Maybe I will write it here. So my first equation, I bring the 2 over with a plus sign to the left, and negative y I change with a positive y. It's going to be something like that, right? So that's my first equation. So I just isolated y from it. So then for each of these x's, I will be able to find y. So for x equal to -1/2, looks like y will be I just copied that -1/2. So y will be a fractional, looks like. So y will be 3 times -1/2. And then we have this +2 with it. So it'd be -3/2. And instead of 2, I can write 4/2. 4/2, because 4 over 2 is 4/2. It's a good idea to always get the same denominator, so it'd be 1/2. And that'd be the point of intersection with coordinates, remember, x and y. So -1/2 for x and +1/2 for y. So we do have 2 points of intersection, and that's the one you can see here, I guess. And then second was with x equals to 2. And when x was 2, to get y, I need to, well, just repeat this process again. So y will come as a 3 times 2 plus 2. And this will be 6 and 2, which is 8. So the other point of this will be with coordinates 2 for x and 8 for y. And that's it. I found my solution for the system, 2 points. And well, I just wanted to mention this kind of systems. You don't get to see them very often, but the idea is to, well, just follow same rules as before, eliminate if you can, or else substitute. In fact, they decided to do the substitution here and then plug it in the equation, which is analogous process. But then when you find 2 answers for one variable, well, automatically you get 2 answers for the other variable that correspond. Interesting, right? So anyways, I think I should discuss the midterm exam. So I hope those that are not here will watch our recording eventually. So I always give my midterm in the format that utilizes last digits of student ID. So let me maybe clear this little, it's too much mess, right? Share again. No, nice and clean. So the midterm will be this Friday. And it will be in the same form, but there'll be two problems. So there is a problem number one here, and there'll be a problem number two. So for the midterm, hard time to write on this computer. I had to change computer. So getting used to it a little bit. Will be this Friday. And on the midterm will be two exercises. And one exercise will look pretty close to what you received by email from me. So it'd be something that we have here, but it's going to utilize your last digit of student ID. As a student of this college, everybody has a student ID number. So I made up 1, 2, 3, 4, 5, 6, and I use a 6, the last digit, to put in this equation. And this way, different students are not going to get the same answers. So students will get different answers. So you can practice to do the problem. It's related to completing square. Notice I just put only one completing of square question here. So only one variable for completing a square. So let me put this instead of variable letter y. We need to factor out this minus. Y squared.
Wait, excuse me.
Yes, please.
So for every problem, we have to use the last two digits to solve every question that's on the midterm.
For problem number one, you use last digit because there is only one place here. So for problem number one, if b is 6, for example, then I put 6. So it's going to be number 7.
And that goes for every other problem on the midterm or just the midterm practice?
So the midterm is going to have two problems. Problem number one, you will use last digit. There will be problem number two. And for problem number two, you will use a digit before the last. So for problem number two, you will use the digit before the last. So there'll be only two problems, problem one and problem two. It's not going to be a big midterm.
Wait, the midterm is only gonna have two questions?
Two questions. Yes.
And the first one we plug in. Okay, never mind. All right, I got it. Thank you.
Yeah, you plug in one digit for one problem and the other digit for the other problem. Two problems, two digits. If you have different difficulty to do that, I will be logged on Friday into Zoom class, and I can always clarify. So please don't worry about this. Everything will be fine. I'll be around, so you'll be able to do this. And I just gave you an example, very, very similar to what you're going to see on the midterm. So what you need now is to make sure that you completed square, because looks like we are dealing with hyperbola graph, right? So you're going to need to deal with y's, and I need to take a half of what's with y, because we have y squared term and we also have y term. So we always take the number with y divided by 2, so you get 1. So you add that number 1, and then you also subtract it. So plus minus 1. So this way we do the process of completing squares. And on the other side, I got there were 7, and that will depend on your last digit of student ID. So if that was not 6, if that was 0, then you would have had 1, and so forth. If that was 9, then you would have had 9 plus 1, which is 10. So I'm making it make sure that not everyone in class gets same answers. So that's the reason why. But the solution process is same. The answers will be kind of similar, but they will be not identical. And that's the point. So those y terms will be put in the parentheses squared on the outside, and y, and the last term here in this little group of three terms, 1, right, will be this plus sign. And I completed square, and this is great because now whatever is left, I need to put in the standard format for the hyperbole equations. So let's recall what that was. First of all, I need not to have these parentheses. So I'm gonna negate that y plus 1 in the parentheses squared. And I also going to change sign with -1 because it's plus, right? Two minuses. So basically I kind of distribute this minus over here and over there. And this is parentheses. And x squared still present. And there's still 7. So now I need to work on the right side. Remember the shape of equation for hyperbola. X minus h squared. And then divide this by square of a. And then plus, actually minus y, subtract k squared, right? So center was that pair with coordinates h and k. And that's over b squared. And this is equal to 1. So that way I have my hyperbola. And the remarkable pair of numbers such as center, and its radius. So center was pair h comma k, right? And there was no radius, but there was a and b that we used to graph. So now this goal is going to be produced here by producing number 1 on the right side. So the key part was to have that number 1. So now this is our goal. So looks like a little by little I will get there. So what I already see is the center, and that's a good start. So looks like we have clean terms in the parentheses squared. And now we need to get that entire equation divided by number 6, right? So I have to put 6 in denominator here to produce 1, and then to pay the price for it. So I have to put over 6 and here and there. And this will enable me to finally see those A and B that happen to be the same numbers. So 1 is produced. Now, what I do instead of 6, I do this square and square root procedure. So it's a square root from that 6 and also squared. And the same exact thing I will do here with the other piece. So this y plus 1 in the parentheses squared will stay, but what I have is my square root 6 and squared. So it's a standard thing. If you can't square root 6, okay, but you can't, so just leave it alone, because these two guys are our so-called A and B, right? So this A and B are the ones that I also found. So A is a square root 6, and so is B. Okay, doesn't matter to us, whatever they are. We're gonna use those to graph. So the equation of this exercise is graph. And to be able to graph, I really need to get this so-called asymptotes of hyperbola. Now, center of it will be with coordinates 0 because I don't really subtract anything from x, so it's like -0. And -1 is for second coordinate because we always change the sign, right? It's like what we subtract. We subtract -1. And this is great. Now I prepare to be able to get those two branches of hyperbola. So we always start with center 0 -1, so someplace down below. Then I go to the left and to the right by square root 6. Square root 6 is more than square root 4, so it's more than 2, a little bit more. So I go to the left, then to the right, and the same up and down. So I produce like a little square here. And the key idea was find its diagonals. Diagonals, so we know what asymptotes of hyperbola are. And now the key part to find out, are we on the left and the right or on the top and the down of the graph? And it's left and right because x squared is positive. So we need to be, wait, looks like we have somehow like that. So the only part that actually is a graph are two yellow branches for this hyperbola. Two yellow branches. And everything else is helping us to produce the graph. But you should show your work for credit. Because I know that sometimes people just use some graphing device, and that device gives them the graph. And well, I can give some partial credit for you to know technology, but remember, we did so many problems, and I always do solve them. So you need to show work. That's important. That's what it says here to get a full credit for the exercise. So please make sure that you do this, and to be able to do this, you need to do the same exercise again. That's why I sent it to you for practice. So now I solved it. So you can do the same, but use your own last digit of student ID. And that'll be the best practice before this coming Friday. Because on Friday, I'm going to email you the midterm. So it's not going to be practice, it'll be actual midterm with two problems, as I said. And you can take the whole day to do it. So I'm not going to limit you in terms of time. You can just take your time. Do your best. You want to double check, triple check. Sure. As long as I get it. So on Saturday, I plan to look at it and grade it over weekend and post your updated grade on Canvas. So I will include grade for the midterm, and I put the course grade. So it'd be a busy weekend for me to check it. But I noticed that it was a busy weekend for some people in class already because they turned in their homework, and I was very happy. So I got emails with homework, and I give full credit for it. So if you finishing with your homework, please do that before Friday. Yes, I will accept it later as well, but it'd be good if you finish up with homework before Friday. So I get your email, and that way I will include also your homework as a part of your new course grade. So I will be asking you also to send me your homework on this Friday. And I already mentioned that homework will include the excuse me, lectures. I actually put them, I think, somewhere on the YouTube, right? I sent you the link. Yeah, I sent. So maybe I will clear this because it's all recorded already. If you want to look at it again, you can definitely check out the recording that I will email to you as usual in a couple of hours. So back to this lectures. So I put first 10 lectures on the YouTube because I think that'd be good enough for you to do the homework for this midterm. So I asked to do a couple of problems from each lecture. So you can do the same exact exercises like here. There's problem 23, problem 11. Because I don't like 11. I like to do 27. Sure, you can do whatever you like. It's up to you. I ask you to do 2 problems from each of these lecture. You can do the same problems, or if you like, you can do different problems. It's up to you. I just want you to practice a little bit. And send me this practice by email. Don't upload anything to the Canvas. I have hard time getting it from Canvas. Sometimes it doesn't open, so it's always some kind of issue with Canvas. Just make a picture and email it to me as an attachment. You have my school email. That's the one that I use every time to send you some emails. So you can just send me back to the same email, and that'd be the way I ask you to turn in your homework, and the same way with the midterm. So for the midterm, you can also send me a picture of your work, or if you can scan it, you can scan it. That's up to you. Whichever way you prefer, so you can send me your work that way. So
And I have a question, sorry. So in the homework is only going to be the just to make the one problem for each section, right? Correct.
so here, 2 problems.
Oh, 2 problems. Okay.
Yeah, here, 2 problems. So from each of these lectures, you can do a couple of exercises, 2 problems.
Okay, perfect. Thank you.
Yeah, so I don't ask you for all of the other lectures we did, because there was another couple of weeks of class, so there were problems that related with those a little bit less pleasant stuff, such as 11.6, right? Especially ones here like 11.5. They're quite tedious, so I don't ask you to get into those. That's okay. So you can just see there were problems here with these various matrix-like structures. I believe the last section in those lectures was, I believe, 11.3. So it's going up to 11.3, and that way you will have a little less to worry about, right? And if you already did a little bit more, that's fine. You can send me that. And I guess that'd be our plan for this week. So on Wednesday, I plan to answer your questions and do one of the exercises that's related to calculated determinants. So the last section for the midterm will be 11.3. So I will ask you to do one of these determinants, and on Wednesday, I plan to just pick one from this group and do it. So that'd be our Wednesday's plan. So try to catch up with homework and see if you have any questions, please. Bring them to me on Wednesday. and I'll let you go and start to put your homework together. So if you did not do that yet, if you already sent it to me, that's great. If not, well, try to catch up and email me whatever you've done. And that's pretty much all I wanted to talk about. So I'm going to stop recording them. And see if anything else, please ask.